In the previous lessons, we learned how to draw Lewis dot structure from a chemical formula and based on the VSEPR theory, which stands for valence shell electron pair repulsion. And from there, we can actually determine the shape of molecules, and this table right here summarize some of the common molecular geometry or shape in terms of the bond angles as well as the name of the shape. Well, the first thing we need to realize is that if you notice, this would be the central atom right here. And the central atom is surrounded by groups, okay? And in this case, how many groups do you see? There are 2 groups, okay? Why am I referring to groups rather than the word bond? That because this could be a double bond, this could be a double bond, or it could be a triple bond. And the key thing is group. And within this 2 group, for the basic shape, notice it doesn't have any lone pair electron, okay? When you have 2 groups without lone pair of electron, we have a shape that is considered linear. Think of the word line. Then what happens when we have 3 groups? Of course, after 2 groups, now we have 3 groups. And notice before we get to 3 groups, look at the bond angles. It is 180. Well, think of a line. A line cut a circle in half. So you can think of a circle is 360. And what's half of a circle? 180 degree. Then we look at the central atom with 3 groups surrounding it. Notice again, it is groups, okay? So one of these could have a double bond as well. And when it has this 3 group, look at this. We take 360 divided by 3, that will give us 120. So each of the angle is 120 degree. And the name for this is trigonoplanar. Think of tries in 3. But what happens when one of the group become a lone pair? Notice lone pair electron has more repulsion, so it takes up more space, okay? And if that's the case, what's going to happen is going to push this 2 down. It's going to push this group down here. So therefore, the degree would be less than 120 degrees. So it's less than 120 degrees between the 2 groups, okay? So keep that in mind. And notice the shape is no longer trigonal anymore, but it is considered bent. And the word bent, you already know exactly what it's like when you have a stick and you bent it. In this case, it looks like that. Then after 3 groups, we would have 4 groups, of course. And 4 groups again. What we have here is, think of the word 4. 4, the prefix for 4 is tetra, and the word is tetrahedral. And one thing you notice the word planar is not on here, right? That's because it doesn't exist as a plane. It's actually, look at this right here. This is pointing toward us, and this is pointing toward away from the central atoms. So you have to realize that when we have 4 groups, we have a degree of 109. There's no trick to memorize. You just have to memorize it. That's pretty much it. And then if one of those groups become a lone pair, guess what happened? Remember, the lone pair has more repulsion. So it's going to push the remaining 3 groups toward each other. And that's the reason why it is less than 109 degree. Okay? And what happened now when one of the other one become a lone pair? So now you have 2 lone pair. Of course, now it's going to push this 2 groups together more closely, so therefore even less than 109 degree. And we again consider this as bent, just like we have in group 3. And try to imagine this when you determine the shape of the molecules, okay? And that is all you need to memorize about the shape of the molecules, based on the VSEPR theory.